Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study topic called quantum numbers. So what are quantum numbers? These are the variables of the wave function psi, which gives the address of the electron around the nucleus in an atom. The wave function psi, the Schrodinger wave equation, which we have done in the previous video. So let's talk about it. What are the quantum numbers? So these are the variables of the wave function. I'm writing these are the variables of the wave function psi, variables of the wave function psi, which gives the address of the electron around the nucleus in an atom, around the nucleus in an atom. So whenever we try to find the address of any person, how do we find that? In which country the person is living, in which city of that country, then in which street of that city, and then in which house number of that street a person is living. So how do we find the address? Firstly, we look for the country, then we look for the city, then in city we look for the street, and in street we look for the house number. This is the way we find the address of any person. So when we have to find the address of electron, how do we find that? Firstly, we will look for the shell in which the electron is present, then in which subshell of the main energy shell, then we will look for the orbital of that subshell, and then we will finally look for the spin of the electron in that orbital. So that's the address of electron. Firstly, we will look for the shell, then subshell, then orbital, and then finally the spin. So this is the method of finding the address of the electron. Now, there are 4 variables of the wave function. That 4 variables are called the quantum numbers. Now, the first variable is principal quantum number. I'm writing principal quantum number. The principal quantum number is designated by a small n. Then the principal quantum number tells about the shell. Now the second variable is azimuthal quantum number. The second variable is azimuthal quantum number. Azimuthal quantum number is designated by a letter small l, and it tells about the subshell. Then we are having third variable called magnetic quantum number. Magnetic quantum number, and it is designated by a small m, and magnetic quantum number tells about the orbital. And then finally we are having spin quantum number. Spin quantum number is represented by a small letter s, and this tells about the spin of the electron. So we are having 4 variables. The 4 quantum number, the principal quantum number tells about the shell, azimuthal quantum number tells about the subshell, magnetic quantum number tells about the orbital, and then finally the spin quantum number tells about the spin. So let me repeat the address of the electron once again. Firstly, we will look for the shell, and then in which subshell of that shell, then in which orbital of that subshell, and then The spin of electron in that orbital will give me the exact address of the electron, which is represented by the four quantum numbers: the principal, azimuthal, magnetic, and the spin. So let's talk in detail about the principal quantum number. My first topic is, first quantum number is principal quantum number. Principal quantum number. Now, it describes the average distance of electron from nucleus and provides the main energy shell in which the electron is present. Now, principal quantum number, it gives the information about it gives the information about the average distance of electron, about the average distance of electron from the nucleus, and provides the main energy shell number, main energy shell number in which electron is present. As the main energy shell number increase, the average distance of electron from nucleus also increase, and this quantum number is represented by a small n. This quantum number is represented by small n, and this quantum number is always a positive integer. I am writing this quantum number is always a positive integer and ranges from 1 to infinity, and ranges from 1 to infinity. But only values from 1 to 7 has been established yet. But only values that have been established yet are from, very importantly, 1 to 7. In the next lectures I will tell you about this thing, why up to 7 only. So now let me write one thing. When the value of n ranges from 1 to 7, we are having some another representations also. Now the shell number 1, 2, 3, 4, 5, 6 and the 7. The first shell has another name called capital K, the K shell. The second one is L, the third one is M, the fourth one is N, fifth one is capital O, the sixth one is capital P, and the seventh one is capital Q. So These shell numbers are also designated as these letters, these alphabets. Like the first shell is K, the second shell is L, the third shell is M, the fourth shell is N, the fifth shell is O, the sixth one is P, and the seventh one is Q. Now, that's all for principal quantum number. So, the principal quantum number tells about the main energy shell in which the electron is present. Now, let's talk about azimuthal quantum number. I'm writing azimuthal quantum number. This quantum number, the azimuthal quantum number, represents the subshell within the main energy shell in which the electron is present. So I'm writing this quantum number represents the subshell within main energy shell in which electron is present. Now, azimuthal quantum number is represented by a symbol small l. This is the small l. The azimuthal quantum number is represented by a small l symbol. Let me write this thing again. It is represented by small l. Now, for any given value of n, the L can have integral values from 0 to n minus 1. So I'm writing for any given value of n, for any given value of small n, that's the principal quantum number, the value of L, the value of small l will range from 0 to n minus 1. That means if we are having the value of n to be assume 4, then your values of L will be 0, 1, 2 and 3 only, because 4 minus 1 is 3. So the values of L will be 0, 1, 2 and 3 for the value of 4 of n. So when the value of n is 4, the value of L will be 0, 1, 2 and 3. Let me write this thing. For example, if you are having n to be 4, the values of L will range from 0 to n minus 1, that is 0, 1, 2 and 4 minus 1 is 3. So that's it. Now, each value of L corresponds to a subshell. Let me write this thing. Each value of L corresponds to a subshell as represented now. When the value of L is 0, that stands for smallest subshell. that is S subshell. When the value of L is 1, it represents P, the P subshell. When the value of L is 2, it represents D subshell. And when the value of L is 3, it represents F subshell. Now, the value of L also tells about the shape of the orbitals occupied by the electrons. The value of L also represents the shapes of the orbital in which electrons are present. So that's all for azimuthal quantum number, which have given information about the subshells within the main energy shell in which the electron is present. So the value of L will range from 0 to n minus 1. For example, if I am having the value of n to be 4, the value of L will be 0 to n minus 1, that is 0, 1, 2 and 3. That's it. So each value of L corresponds to a subshell as represented. The 0 stands for S, 1 stands for P, 2 stands for D and 3 stands for F. So now let's talk about the third quantum number called magnetic quantum number. Now I'm talking about magnetic quantum number. Now, the magnetic quantum number represents the orbitals within subshell where electron is present. This quantum number specifies the orbitals within subshells where electron is present. Where electron is present. It is represented by, the magnetic quantum number is represented by small m. Now, the value of m for each value of small l, the azimuthal quantum number, will range from minus L to plus L. The value of m for each value of L will range from minus L to plus L. Let me give you an examples. So I'm making a table. Assume the value of L is 0. Then the value of m will be only 0. Now assume the value of L to be 1. The value of m will be minus L to plus L. The value of m will be minus 1, 0 and the plus 1. Now Let's take the value of L to be 2. The value of M will be minus root 2 plus 2. So that will be minus 2, minus 1, 0, plus 1 and the plus 2. Now, as we know, this 0 stands for S subshell. How many values of M we got for the S subshell? The only one value. Take 0 as the value. We got only one value. That means the S subshell will have only one orbital. Now let's talk about 1. The value 1 for L represents the P subshell. For P subshell we got the three values, that's minus 1, 0 and the plus 1. That means the P subshell has 3 orbitals. Now let's talk about the value of 2 for the L. The 2 stands for D subshell. For D subshell we are having 5 values, that's minus 2, minus 1, 0, plus 1, plus 2, and that stands for 5 orbitals. The D subshell will have 5 orbitals. Now these orbitals also have their specific names also. So let me write that also. Now when M is 0, that stands for only S. When let's talk for the P. For P, the minus 1 stands for Px or Py. The 0 stands for Pz, and again plus 1 stands for Px or Py. So these values are fixed. You have to learn them. Now let's talk about the D. We are having 5 values for the M, minus 2, minus 1, 0, plus 1, plus 2. So minus 2 stands for dx square minus y square or dxy. Minus 1 stands for dzx or dyz. 0 stands for dz square only. Plus 1 again stands for dzx or dyz, and plus 2 again stands for dx square minus y square or dxy. So that's all about the magnetic quantum number, which have given us information about the number of orbitals in a particular subshell, or we can also specify the orbital within subshell where electron is present. So hopefully that's all. Hopefully you all clear the magnetic quantum number. So now let's move to the next quantum number, that's the spin quantum number. Now let's talk about the spin quantum number. Now I'm talking about spin quantum number. Now I'm writing when an electron revolves around the nucleus, it is also spinning about its own axis, comma, it is also spinning, or you can say it is also rotating on its own axis, either clockwise or anti-clockwise. Now the spin counter number gives us information about that rotation, about that spinning. So there are only two possible values for the spin counter number. So first of all, I'm writing the spin counter number gives information about the spin of the electron. Accordingly, the spin counter number will have only two values, whether it will be a plus half for the clockwise motion or it can be minus half for anti-clockwise motion. Spin counter number is represented by a small s symbol. Now, according to the spin, the maximum of two electrons having opposite spin can remain in one orbital. So I'm writing, it's a very important point, The maximum of two electrons with opposite spin can remain in one orbital. That means the one orbital can accommodate only two electrons. One orbital can accommodate only two electrons and they must be of opposite spins. One is plus half, another one is minus half. So that's all about the quantum numbers. So now first of all, let's design a city for the electrons, then we will talk about their filling in that city. So first of all, I'm writing let's design country, city, street and different house numbers. Let's design all this thing for electrons, then we will talk about the presence of electron in a particular house. So let's first of all talk about the complete country, city, street and the house number. So that means let's talk about the complete shell, subshell, orbitals and the electrons. One shortcut I'm writing over here, and it is nth shell. Nth shell will have n number of subshells and square number of orbitals and 2n square number of electrons. So now let's talk about the first shell first. We are talking about the first shell. In the first shell, we will have only one subshell. Now 1 square stands for 1 only, so it will have only one orbital. And 2n square, now 2 into 1 square comes out to be 2, so it will have only 2 electrons. Now let's talk about the second shell. Second shell will have two subshells. Two square orbitals means 2 square orbitals comes out to be 4 orbitals. One orbital has 2 electrons means 4 orbital will have 8 electrons, or you can say 2n square electrons. So it comes out to be 2 into 2 square comes out to be 8. We got the 8 maximum of 8 electrons in the second shell. Now let's talk about the let me take one more, third shell. I'm talking about third shell now. Third shell will have 3 subshells. 3 square stands for 9, the 9 orbitals. And 2n square, where n is 3, so 2 into 3 square comes out to be 18 electrons. So now let's talk about all the shells, like first shell, second shell and third shell, in a bit detail. So let's come for the complete detail for the first 3 shells, first, second and the third. For that, let me recapitulate the previous formulas. When the value of n, the main principal quantum number is n, let me take it like the value is small n, then the value of L will be 0 to n minus 1, and we know that for the values 0, 1, 2 and 3 for L, the 0 value of L stands for S subshell, 1 stands for P, the 2 stands for D and the 3 stands for F. Now let's talk about the magnetic quantum number. For each value of L, it will be minus L to plus L. Now let's talk in detail about the first shell. I'm writing first shell. Here n is equal to 1, then L will be only 0. Now 1 and a 0 stands for 1, 0 stands for S, so it comes out to be 1S. Now M stands for only 0, it again comes out to be only 1S, because M is only 0, the only one value, the only one orbital, so you can also name that orbital as 1S. Now what you can observe over here, you can observe that when the value of n was 1, the first shell, how many subshells you got? Only one. I got the one subshell. How many number of orbitals we got? Accordingly m, only one orbital. So you can come over here. So hence the first shell will have one subshell, one orbital and 2 electrons, hence proved. So now let's talk about the second shell. Now let's talk about second shell. Here n is equal to the 2. The value of L will be 0 and 1. Now we got n to be 2, L to be 0. The 2 and 0, the 2, 0 stands for S, so it comes out to be 2S. Now 1 stands for P, it's of second shell, it comes out to be 2p. So here how many subshells we got? One is a 2s and another one is a 2p. We got here two subshells. We got two subshells. Now let's talk about the m. For the value of 0, the m will remain 0. For the value of 1, we will have three values: the -1, 0 and the +1. Now for the value of m, the 2 and the 0 stands for 2s only, because it's only one orbital. Now for -1, you can write it like 2px. For 0, we can write 2pz, and for +1, we can write 2py. How many orbitals we got? The 2s, 2px, 2pz and a 2py, we got total 4 orbitals. So we got over here 4 orbitals. Now let's talk about the third shell. Now let's talk about the third shell. Here n is equal to the 3. So the value of L will be 0 to n minus 1. N minus 1 is 2. So the values are 0, 1 and the 2. Now 0 stands for S, is of third shell, is a 3s. 1 stands for P, is of third shell, 3p. 2 stands for D, is of third shell, so it's 3d. We got the three subshells, 3s, 3p and the 3d. So we got three subshells. So now let's talk about the m. For 0, it comes out to be 0 only. For 1, it comes out to be -1, 0 and the +1. For 2, it comes out to be -2, -1, 0, +1 and the +2. Okay. Now 3 and 0 stands for only 3s. Now -1. Let's talk about the -1. So it's 3px, 0 is 3pz, +1 is 3py. Now let's talk about the d orbitals. The orbitals for 3d subshell, it comes out to be 3d x and y. -2 stands for 3dxy. The -1 stands for 3dyz. The 0 stands for 3dz square. +1 stands for 3dzx and +2 stands for 3dx square minus y square. So these are the specifications for the orbitals. So how many orbitals we are having? We are having 1, 2, 3, 4, 5, 6, 7, 8 and the 9. We are having total of 9 orbitals. So that's the main shell was 3. The 3 square stands for 9. So I have proved that is there are 9 orbitals. Now one orbital has only 2 electrons. So let's calculate the number of electrons also. Now let's come to the first shell. The 1s. In one orbital we will have 2 electrons. In 4 orbitals we will have 8 electrons. By the relation that one orbital will have 2 electrons, the 4 will have 8 electrons. Now the 9 orbitals will have total of 18 electrons. So that's the city that I have designed, in which we have taken the shell number, then I have found their subshells, and then I have found their orbitals, and then finally the maximum number of electrons that orbital or subshells or that total shell can accommodate. So hopefully you all got the today's topic. This topic is very important, and it is going to help you in the whole chemistry, specifically in the organic chemistry. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.